you're good to go.
I subtracted the x from both sides, so I got -2y is sine of negative x plus 7 divided by -2, and then I got y times 1 of x minus 3.5.
Okay. Cody, tell us, do you agree or disagree?
I disagree because I just got something different, but I probably also got it wrong.
Okay.
Because I didn't really change I divided -2 by 2. So I got y equals 1/2 x is less than 2.5.
I might have been strong too, but whenever I said slope intercept form, I thought about 2 points. So I kind of said it for x and y.
Oh, okay, so that would be what you do if you're checking to see if something's a solution.
Okay.
You plug in a point.
Slope intercept form is y equals x plus 3.
Maureen?
Are we supposed to change the sign before we divide everything, or after?
After you divide by negative. So, yeah, everything's correct. The only thing is where you changed your sign, don't change your sign until you divide by the -2. All right, so you did have x minus 2y is less than 7, and then you subtract the x over to the other side, and you get -2y is less than -x plus 7. Then divide by -2, and when you divide by -2, you flip the sign of the inequality. So then you get y is greater than 1/2 x minus 3.5. Or you could have left it as -7/2. But if I'm on a number line and I'm having to graph the y-intercept of 3.5 or 7/2, I'm going to want to graph 3.5 because I'm going to think, oh my gosh, where is 7/2 at on a number line? And you just have to count by 7/2. Thank you. Go ahead and have a seat. All right, so if you were to graph this, okay, so -3.5, I know between -3 and -4, so 1, 2, 3, it would be right here in the middle. But if you graph -7/2, if you had your slope intercept as a fraction, that means 7/2. So instead of counting by ones, you count by a half. So you start here, and here would be 1, 2, 3, 4, 5, 6, 7. So that's what 7/2 means. It means count by halves and count 7 of those halves. Okay, so that's my y-intercept is -3.5, and my slope is +1/2. So that means you go up 1 and to the right 2. Okay, so if I was at -3.5 and I go up 1, I'm at -2.5, and then go to the right 2. Now, my question for you, would this be solid or dashed?
Yeah.
Dashed, because these points on the line would not be a solution. Okay, and then to find out which side to shade, you test a point. Me personally, I would always test the point 0, 0. So I get 0 is greater than 1/2 times 0 minus 3.5. So you get 0 is greater than -3.5, and that's true. So you shade the side that has the 0, 0 point. Okay, and that's what your quiz was over on Wednesday. Alright.
Until if it was like false or
Yep. If it come out to be false, you would shade on the other side. Okay. Very good questions. What other questions do you have for me? Okay. All right, you can put your bell ringer away. We are going to take notes. And we are starting on systems of inequalities. And could I get someone to check for me and tell me what page of notes this will be? 29? Okay, thank you. So this is going to be page 29 of your notes. 28 is probably 6.1, Systems of Inequalities.
What page was graphing linear? That's what I have for page
28 is linear inequalities, graphing linear inequalities. Yeah.
What was the test called?
6.2, graphing systems of inequalities. Now, on your notes paper in our previous book that we used to use, this was chapter 7, but in our book, this is chapter 6. It's actually chapter 5, but for us, it's chapter 6. So up here at the top of your paper, it says 7.2. Change that to 6.2.
You think that's homework?
You could if you don't finish the worksheet. Now, if you would like to use 2 colored pencils to do your notes in, you can go get you 2 colored pencils. And when we shade, you're going to want to use light colors or shade lightly because there's going to be multiple areas that you highlight. Okay, graphing systems of inequalities, notes. And what page notes did you say this was?
29.
29. And then don't forget, after you put the 29 up there, you need to change this to 6.2 instead of 7.2. All right, so we have to solve a system of inequalities by graphing. Okay, so the first one, so what you need to do is make sure they're both in slope-intercept form first, and then graph each inequality, but on the same graph. Okay, so first I graph y is less than x minus 4. Okay, so my slope is 1, and my y-intercept is negative 4. So graph your b first. So I graph negative 4 on the y-axis. Remember, this is y and this is x. And then since my slope is positive 1, start at the negative 4 and go up 1 over 1. Up 1 over 1. Up 1 over 1. And then use a ruler, something with a straight edge, and draw your line. But you have to remember, it's either going to be solid or dashed. Well, since there's no equal to, it's going to be dashed. Okay, so we're going to draw a dashed line to connect all those points for y is less than x minus 4. Okay, now for the shading area, whenever you shade, you're going to have to shade lightly. Okay, so y is less than x minus 4. I'm going to test the point 0, 0. Okay, so if I test 0, 0, I get 0 is less than 0 minus 4. 0 minus 4 is negative 4, so I get 0 is less than negative 4. Is that true? No, that's not true, so I would shade the other side. But whenever you shade this other side, shade it very, very lightly. Because this is not these are the ordered pairs that are solutions to this inequality. We're trying to find the ordered pairs that are solutions to both inequalities. Remember with a system of equations, when we plugged the point in, it had to work for both? That's what we're doing here. We're trying to figure out which ordered pairs work for both. Well, all of these ordered pairs in this shaded area work for the top inequality. Now we need to figure out which ordered pairs work for this one. And I'm going to do this in a different color. Y is greater than or equal to negative x plus 3. So my y-intercept is 3, so I'll put a dot at the 3. And my slope is negative 1. Negative 1. So that means you start at the 3 and go down 1 to the right 1. Down 1 to the right 1. Down 1 to the right 1. Okay? Now use your ruler or a straight edge and draw your line. And since there's an equal to, this line's going to be solid. So that means that the points on the line are solutions.
Basically, we do what we did the last one, but we just do 2 lines.
Yes. Okay. Now you need to test a point that's not on this line, on this inequality, to know which side of this line to shade. I'm going to test 0, 0 again because it's not on this line. So I'm testing 0, 0. Okay, so I get 0 is greater than or equal to negative 0 plus 3. And negative 0 plus 3 is 0, or I'm sorry, is 3. So I get 0 is greater than or equal to 3. Is that true?
No.
No. So I shade the other side of the line. So shade this side of the pink line. Again, shade very lightly because these are just the ordered pairs that are solutions to this inequality. Okay. Now, what you want to look for is which ordered pairs are solutions to both. Which area represents the ordered pairs that would work for both? Where do you think that area is at? This right here would mean that it's not a solution. If it's not shaded, that means it's not a solution to either one.
There's a triangle
Like right here?
Yeah.
Okay. See how it's where the two colors overlap? Or it's where you shaded twice? Okay. That means all of these ordered pairs here, and I'm going to use a different color. All of these ordered pairs in this area that shaded twice would be solutions to both inequalities. So if you were to pick an ordered pair in this area, it would work for both inequalities. It would come out to be true. So your final solution area is this area right here that I just colored in. So you need to somehow show me that this area is your solution area. You can either go back and erase these, or you can just make this darker than what the rest of it is.
Will it always have a part like that that's like crossing over?
If they don't, then it would be no solution.
Okay.
Okay. Now, the next thing we're going to do is we are going to write down ordered pairs that are solutions to the system. Okay. So to write down ordered pairs that are solutions to the system, you just need to find an ordered pair that's in the shaded area. And we're going to do 4. So pick a point that's in the shaded area. Let's say this point right here. And you just need to write the ordered pair for that point. So there's the x value would be 1, 2, 3, 4, 5, 6, 7, 1. So 7, 1 is in the shaded area. So it is a solution to the system. It works for both. The pink area is a solution to the pink inequality. The blue area is a solution to the blue inequality. The purple, or this one that's shaded in, that's a solution to both inequalities. Okay. Another ordered pair that would be a solution would be this one here, and that ordered pair would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 0.
Can I do like 7 negative 1?
Yes, 7 negative 1 works. That's right there. 7 negative 1 works. Okay. Anyone got a different one? Ariana?
I have a question about like one of the ones that's in like between like the 2 lines.
Mm-hmm.
So you can pick like technically any point into this line.
Any point in between those 2 lines. Anybody got another ordered pair they want to use?
8, 1.
8, 1, yeah, that's right there. You could use 8, 1, 8, 2, 8, 3, 9, 3, 9, 2, 9, 1.
Do we have to use more than 1?
You need to do at least 4.
And all we have to do is write them down, or do we work them all?
Nope, all you gotta do is write it down.
Okay.
Now, next thing. Is if you pick a point on the line, that would be a solution as long as your line is solid. So for instance, this point right here, see how it's on the solid line? That's 7, 1, 2, 3, 7, negative 4. 7, negative 4 would be a solution. However, 7, 3 would not be a solution. So do you see the difference there? 7, -4 would be a solution, but 7, 3, since it's on the dashed line, would not be a solution. No, I do not. Okay, let's do number 2. Y minus 3x is greater than or equal to 6. Okay, so what I need to do first is put this in slope-intercept form. So the minus 3x, I need to add over to the other side, and I get y is greater than or equal to 3x plus 6. Okay, and I graph this one at 6, 1, 2, 3, 4, 5, 6. I put a dot on the 6 on the y-axis, and my slope is 3 over 1. So I start here and I go up 3 over 1. Up 3 over 1, and my line is solid. Because there's an equal to sign. Now I need to figure out which side to shade. I'm going to test the point 0, 0. So I get 0 is greater than or equal to 3 times 0 plus 6. 3 times 0 plus 6 is 6, so I get 0 is greater than or equal to 6. Is that true? Nope.
No.
So shade the other side. So this is on this side, so I'm going to shade the other side. Remember, shade lightly, because these are only the ordered pairs that are solutions to the blue inequality. And we're trying to find the ones that are solutions to both inequalities. So shade lightly. Okay. Negative x minus 2 is less than y. Y is already by itself. It's just on the wrong side. So what I'm going to do is I'm just going to move this y over, and I'm pretty much going to flip my inequality. But what happens whenever I flip this inequality? What do I have to make sure I do? Yeah, that sign's also going to flip. So it's going to, because the mouth has to open up toward the y. So y is greater than negative x minus 2. So the only thing that really changed was the inequality. And that's because the mouth has to open up to the 2. The mouth has to open up to the y. I was looking at the 2 when I said that. Okay, so now I need to graph that. I plot the point at negative 2. And my slope is negative 1. So that means I go down 1 to the right 1, down 1 to the right 1. And it would be a dashed line because it's not equal to. So I use my ruler and make a dashed line. And if you ever mess up and make a solid line and you're using markers, something you can't erase, just write a note beside it that says dash and point an arrow to it. If you're using a pencil, you can just go back and put some marks in it.
I have a question.
Yes.
What if, whenever they cross over, there's 2 spots that look like that are shaded?
There will only be one region where they're both shaded.
Okay.
You won't have 2 different regions you won't have 2 different regions. You'll just have 1 region or 0 regions. All right, so now let's test the point 0, 0 again, but in the new one. So 0, 0, you get 0 is greater than negative 0 minus 2. So 0 is greater than negative 2. Is that true? Yeah. So I shade the side with 0, 0. So I shade this side of the line. Now, the solutions would be the parts that we shaded both times. We shaded it in the blue one and we shaded it in the pink one. So which area shows it shaded in both the blue and the pink? Yeah, this up here at the top. Perfect. So that area I'm going to shade in and make sure it's darker than the rest of it. So I'm going to shade in this. What these lines are called are boundary lines. They tell you where your region ends. It's the boundary points of your region. Okay, so this area would be my solution area. I'm I'm going to pick the first point, and then I'm going to call on other people to pick the other 3 points. Now remember, if the line is solid, you can pick a point on the line. And if no one's picked one by the 4th one, I'm going to have someone pick one on the line. If the line is dashed, you can't pick it. All right, so the first ordered pair I'm going to pick is going to be this point right here. Okay, so that's this one. So that's 1, 2, 3. So -3. 1, 2, 3, 4, 5, 6. -3, 6 is one solution to the system. -3, 6. All right, Rebecca, what's another ordered pair that would be a solution?
3, 7.
3, 7. Okay, so let's try 3, 7. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. Now 3, 7 is only in the pink area. -3, 7. Okay. So here's -3, 1, 2, 3, 4, 5, 6, 7. So that's right here. So that works perfect. I figured that's what you meant, but I just wanted to be sure. All right, Brandon, what's another ordered pair that's a solution?
1, 9.
1, 9. Okay, so start here at 0. Go to the right 1. 1, 2, 3, 4, 5, 6, 7, 8, 9. Good job. That's actually on the line, and the line's solid, so that works. All right, Aubriana, what's another one? 8, -1. Okay, so if I go to the right 8, 1, 2, 3, 4, 5, 6, 7, 8, and down 1, that actually leaves me in the pink area.
So -8.
Okay. So you'd go to the left 8, 3, 4, 5, 6, 7, 8, 1. That would be here in the blue area.
This is confusing.
Remember, the X goes first.
1 negative. Oh my gosh.
Maybe -1, 8. Okay. All right. So -1, 8. Where it would be, that means go to the left 1 and up 8. So go to the left 1. 1, 2, 3, 4, 5, 6, 7, 8. That would be right here, which works.
Yeah.
-1, 8. Perfect. Yeah. Remember, your X value goes first. Okay. All right. Let's do number 3. X is less than 6. Oh, there's no Y. I think I remember that. Whenever it's X equals a number, would that be going across or going up and down? Yeah, it's going to be vertical. Remember, Vux, V-U-X, vertical. So X is less than 6. Why am I seeing a 2?
If it's true, you color the side of the dot, right?
Yes, if it's true, color the side of the dot.
I'm confused on how we're getting the points. I thought I had it, but like, why do you have to go in a certain direction?
Because if you start at the origin,
Yeah.
and the first number, if it's negative, you go to the left, and if it's positive, you go to the right.
Oh.
And when the second number start at the origin, or start wherever you're at, let's say it's -2, 4. So -2 tells you to go to the left 2, and then the second number tells you to go up or down. If it's positive, you go up. Negative, you go down. So -2, 4, you would go to the left 2 and up 4.
Okay.
All right, so X is less than 6. That would be a vertical line at the 6 on the X-axis. So here's 1, 2, 3, 4, 5, 6. And it's going to be dashed. So I need to draw a vertical line that's dashed. Okay, and I want to test the point 0, 0. Okay, so for X is less than 6, 0, 0. This is X, this is Y. There is no Y, so I would just do 0 is less than 6. And is that true or false? Perfect, that's true. So I shade the side that has 0, 0. So very lightly, shade all of the left side.
I forgot how to put a decimal into a fraction.
Divide, like 1/2 is 1 divided by 2.
So 0.25 would it be?
Oh, 0.2, well, what did you divide to get 0.25?
-1 divided by -4.
Okay, so you would just put -1 over -4, which simplifies to positive 1 over positive 4. Okay. All right, now let's do the next one. In order to get this one in slope-intercept form, first I have to subtract x over to the other side. And I get negative 4y is less than or equal to negative x minus 8. And then you divide everything by negative 4. And what do I have to remember since I divided by a negative? Flip your sign. Negative 1 divided by negative 4 is positive 1 over 4, x plus 2. Okay, plot the 2 on the y-axis, which is right there. It's kind of shaded in, so you have to be careful. So 1, 2. And then my slope is positive 1 over 4, so I go up 1 over 4. Up 1 over 4. Again, this is why it's important to shade lightly, so it's easy for you to count the lines and see the lines. And it looks like that line is going to be solid. Okay. Now I need to know which side to shade, so I'm going to test the point 0, 0, because again, it's not on the line. So I get 0 is greater than or equal to 1/4 times 0 plus 2. So 0 is greater than or equal to 2. Is that true? No. So I put an X there. And I shade the side that does not have 0, 0. So I shade above the line. So we shade all of this here above the blue line. Now your solutions are going to be the ordered pairs in the region where it's blue and green. So which region is blue and green? Yep, at the top on the left. So let's color that one in even more with a different color, just so I can tell that this is my solution area. I like systems of inequalities because it makes me feel like I'm coloring, which technically I guess I am. Okay, so that big dark area is my shaded region. Okay, now next, you're going to give me solutions to the system of inequalities. All right, Cody, give me an ordered pair that's a solution to the system, please.
-8, -1.
You said negative what?
-8, -1.
Okay, so start at the origin. -8 means go to the left 8. And -1 means go down 1.
I meant not -9.
-9, -1. It's almost there, but not quite. What about -9, 0? At this point right here, can I use that one? Okay.
Would -8 positive one work?
Okay, let's count. 1, 2, 3, 4, 5, 6, 7, 8, and positive 1. Yep, that's in the shaded area. Ariana? -9, 3. So go to the left 9. Up 3, which is right here. All right. Now, Cody, were you trying to find a point that was on the line?
Yes.
Okay. You want to look at, see if you can see a different point that's on the line? 0, 2. Yeah, it's right there and it's solid. So that one works. Morgan? -4, 1. 1, 2, 3, 4. Ooh, good job.
Do we have to always find one that's on the line? Like,
Not always, but I just want you to get practice doing it, because I'm only making you do this because on some of your assignments, after, like, it'll show you a graph of a system of inequalities and it'll ask, is this ordered pair a solution? And I want you to be able to look at your graph and say yes or no. So, like on today's worksheet, you won't have to do this part. You'll just have to graph it and show me your system.
oh, so we don't have to show the solutions?
No, only sometimes. Sometimes it'll ask you, but not every time. And also, I wanted to make sure you understood that if the line is solid, then yes, they're points, they're solutions. But if the line's dashed, you can't use that one. So like we would not be able to use the ordered pair 6, 6, 4. We couldn't use that point, 6, 4, because it's not a solution to this one. Because 6 is not less than 6.
And then it's a 9 line, you can't choose point there. If it's on a straight line, you can't.
Perfect.
So on the worksheet, we still color it dark though where the solutions would be.
Yes, yes. Alright, so for your assignment, you're going to go ahead and get started on it. And then whatever you don't finish will be your homework. I would like for you to finish it, but I know that you possibly could not.
Is there a lot of problem with it?
I'm about to show it to you. Okay, here's your worksheet. It says, graph each pair of inequalities below and indicate the solution set of the system with cross-hatching or shading. We've just been shading. The cross-hatching or shading, if extended, would cover a set of 3 letters. Print those letters in the 3 boxes at the bottom of the page that contain the exercise number. So, for instance, if on our notes, these are from 3 years ago, but like this area here was our solution area. If I were to extend this area, it would be coming out here, okay? Now, on your worksheet, there's 3 letters right there. Let's say it's TWO, okay? So if you were to extend it and it were to cover up those 3 letters, TWO, down here in number 1, in those boxes, you would put TWO, okay? So your shaded area, your final solution should extend to either the FRO, the TOO, or END. And it looks like there's 6 problems, okay? And some of them are in slope intercept, some are not. Yeah, as I mentioned, you'll have the rest of the class to work on it. I'll be walking around passing out papers in case you have any questions.